So far, you have learned how to write and graph inequalities. Now we're going to learn how to solve them. A couple of things that you're going to learn in this particular topic are how we solve inequalities, and we can say how we use addition, subtraction, multiplication, and division to solve them. You will also learn how to graph the solution set. The graph below shows the number of home runs that the top hitters on the baseball team hit last season. Write an inequality that compares the number of home runs that Nate hit to the number of home runs that Josh hit. Okay, so Nate's right here and Josh is right here. It looks like Nate had 15 and Josh had maybe 12. So you could write, it's comparing Nate to Josh, so 15 is greater than 12. Write an inequality that compares the number of home runs James hit to the number of home runs that Mark hit. James looks like he hit 19, and Mark hit 23, it looks like. So 19 is less than 23. Suppose James and Mark each hit 3 more home runs. Write a new inequality that compares the number of home runs James and Mark hit. So if James hit 3 more, that would be 19 plus 3 is 22. And Mark, if he hit 3 more, that would be 26. So 22 is less than 26. Remember, if the arrow points, let me change that. If the arrow points to the left, that means that this is less than. Okay, go ahead and go to your next page. When you solve inequality, you use the same properties that you used when you solved equations. So when you add or subtract the same number from each side of an inequality, the inequality remains true. So for example, 5 is less than 9. If we add 4 to both sides, 9 is less than 13. That's true. If we say 11 is greater than 6, and we subtract 3 from both sides, you'll be left with 8 is greater than 3. That's still true. Okay, the properties are also true for less than or equal to and greater than or equal to. Solve x plus 7 is greater than or equal to 10. When you solve just like we learned in Unit 4 with equations. Use the river. Okay, so I'm going to show this with the river. Draw your river, and then if you're using addition in the equation, like you can see there's addition right here, you'll use subtraction to solve it. That's how you undo the addition. And you must subtract from both sides. So then you're left with x is greater than or equal to 3. Okay? Now, the only thing that is different is that the answer is x is greater than or equal to 3. That means that anything that is 3 or bigger makes the sentence true. Like if you put a 10 in there, 10 plus 7 is greater than or equal to 10. So there's many solutions. In order to show the solution, you show it on a graph. We used a closed-in circle to indicate greater than or equal to, and we graph to the right if it's greater than. We go to the left if it's less than. Solve x minus 3 is less than 9. Again, we will use the river. And in this case, we add 3 to both sides because it's a subtraction equation. And we're left with x is less than 12. Since it's less than, not less than or equal to, we use an open circle. Okay, and we go to the left for less than. Why don't you try A and B? When you finish, please press pause now to answer the questions and then come back and check your answers. Okay, let's check our answers. In order to solve these, we would use the river. This is an addition equation, so we would subtract 2 from both sides, and we would be left with n is less than or equal to 3. Okay, so I'm going to write that over here. N is less than or equal to 3. In order to graph that, we would use a closed-in circle because it's included, the 3 is included, and we would go to the left because it's less than. Let's do the next one. Y minus 3 is greater than 9. So we're going to add 3 to both sides, and then we are left with y is greater than 12. In this case, we would use an open circle because it's greater than, not greater than or equal to, and greater than goes to the right. Your skills for solving the inequalities are exactly the same skills that you used in Unit 4. So you shouldn't have any trouble with this. Go ahead and go to the next page, please. Remember, we also use multiplication and division to solve inequalities. We do the same with equations. If we have a multiplication equation, we would use division to solve it. And if we have a division equation, we use multiplication. Same thing is true as the other properties. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So here, 5 is less than 10. If we times both sides by 2, we would get 5 times 2 is 10, 10 times 2 is 20. 10 is less than 20. 16 is greater than 12. That's a true statement. If we divide both sides by 2, 16 divided by 2 is 8. 12 divided by 2 is 6. 8 is greater than 6. The properties are also true for less than or equal to and greater than or equal to. Let's look at a couple of examples. Solve 5x is less than or equal to 45. Again, use the techniques that you have learned. Use your river. And if it's a multiplication equation like this, we divide both sides by 5 to balance the equation and get x by itself, and we get x is less than or equal to 9. We use a closed-in circle and go to the left. Inequalities are just like equations too. You can always check your answers by picking any number on your graph and plugging it back into the equation to solve. Let's look at number 4. X divided by 8 is greater than 3. In order to solve this, if it's a division, we use multiplication to solve it. So we multiply both sides by 8. These two cancel each other out, and we're left with x is greater than 24. We use an open circle and go to the right. Your turn. You try C and D. Okay? Press pause, do your answers, and then we'll check your work. Welcome back. Hopefully you solved them like this. Use your river, divide both sides by 10 because it's a multiplication equation, and you're left with x is less than 8. Since it's less than and not less than or equal to, we use an open circle and we go to the left for less than. For D, x divided by 6 is greater than or equal to 7. So again, use your river, times both sides by 6. It's hard for me to write it on this one. And you multiply both sides by 6. These would cross each other out, and then you're left with x is greater than or equal to 42. This time you use a closed-in circle because 42 is included, and we go to the right. Excellent job. If you're having any trouble, you can always go back to Unit 4 to review, and you can also stop at this point and ask your teacher for a little more help. The only thing that you are doing different than what you did in Unit 4 is graphing the solutions. Go ahead and go to your last page. Let's look at a real-world example. Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. Let C represent the cost of each bag of favors. 7 times the cost of each bag must be no more than 42. She doesn't have any more than $42 to spend. So we would say 7C is less than or equal to 42 because she can't spend more than 42. To solve that, you divide both sides by 7, and you're left with C is less than or equal to 6. She can spend a maximum of $6 on each party favor bag. Remember this as well. At most translates to less than or equal to, and at least translates to greater than or equal to. That's very important, so try to remember that. I'm going to put a little star by that. Okay? Now it's time for you to do your guided practice. Okay, oops, sorry, my star is moving around, so let's shrink that up a little bit instead. There we go. Okay, time for you to do your guided practice. Please solve each inequality and graph the solution on the number line. Okay, for 3 and 4, it looks like you just need to write an inequality and solve it. Please rate yourself when you are finished to say how you feel about inequalities if you're ready to move on. Press pause, solve the problems, and then come back to check your answers. Welcome back. Let's check your answers. For number 1, you should have had, I need to make this a little bigger. For number 1, you should have had h is greater than or equal to 19. You can place your 19 just about anywhere you want on the number line. You would have a closed-in circle, and you would be going to the right. For number 2, you should have y is greater than 6. Okay, you should have divided both sides by 6. In this case, you would use an open circle because the 6 is not included, and you would go to the right again because it's greater than. For number 3, Joanna's parents give her $10 per week for lunch money. She cannot decide whether she wants to buy or pack her lunch. If a hot lunch at school costs $2, write and solve an inequality to find the maximum number of times that she can buy her lunch. So you know that the inequality should be $10 less than or equal to 10 because she can't spend any more than 10. And every lunch is $2, so 2x is less than or equal to 10. If you solve that, you would get x is less than or equal to 5. That means she cannot buy any more than 5 lunches. For number 4, Tino's Pizza charges $9 for a cheese pizza. Eileen has $45 to buy pizza for the Spanish Club. Write and solve an inequality to find the maximum number of pizzas that she can buy. Well, you know she can't spend any more than $45, so it's less than or equal to. It's $9 for every pizza. So we would say 9p is less than or equal to 45, and p is less than or equal to 5. That means she can buy no more than 5 pizzas. How about number 5? How is solving an inequality similar to solving an equation? Well, you solve them exactly the same. You solve using the opposite operations, just like you did in Unit 4 when you solved equations. So it's exactly the same thing. We just have to graph our solution at the end. Pretty easy, okay? Please go ahead and rate yourself to tell me if you're ready to move on to the next section. Great job on this, and good luck on all your practice problems. Bye for now.